Okay, this will be our second video, and this will be problem 7 all the way through the end. So we're on our test review 5.4, and this is going to be 7 through the very end of it. So decide which scenario, A or B, has the higher power. Explain briefly. Well, first off, let's talk about power. Power is the probability of correctly rejecting the null. All right, correctly rejecting a false null, if you like to say that, but the power is a probability of correctly rejecting a false null. So let's consider a couple things that affect power. All right, so as alpha goes up, as alpha goes up, power goes up, beta goes down. Okay. Another thing, as our sample size goes up, power also increases. So let's take a look and see what we have. Scenario A, test is run with alpha equals 0.01 or 0.1. Well, that's the same as B. So that's going to have no effect because that didn't change. Given the null is 17 and the null is 17, greater than 17. So we're not worried about how far we are yet. Then we have a sample size 70 and a sample size 70. So far, everything's the same. Our standard deviation is the same. But then they say the actual mean is 21 and the actual mean is 19. Ooh. All right. So here we have, this is the claim, and this is the actual, and this is the actual here. Which one am I more likely to reject with? Well, as long as we're moving in the correct direction, the farther we are from the claim, the more likely we are to reject. So our claim is 17, and then type and we have basically a number line. The 17, 18, 19, 20, 21. And the other one is 17, 18, and 19. Well, if I look at A, it's further away. The bigger the lie, the more likely I am to get caught. The bigger the lie, the more likely I am to get caught. This one has a bigger lie, and it's in the correct direction of greater than. So scenario A has the higher power because the actual mean is farther away from the claim mean, making it more likely to reject the null. Essentially, if we wanted to look at this on a diagram basis, we could say this. This is what they're claiming it looks like. And here is what it looks like. Well, gosh, my sample is way over here. Whereas here, I might have more overlap because they're closer together. So closer together has more overlap, farther apart, less overlap. The less overlap, the more likely I am to reject. But basically, I just say the farther away from the claim mean makes it more likely that I will reject. All right, number 8. Again, deciding which has the higher power. All right, scenario A or scenario B. Once again, I look at the alphas. Well, they're the same. The means are the same. The alternative hypothesis, the sample size. Oh, I notice this one has a larger sample. Because it has a larger sample, if I increase sample size, I increase power. So this one has the greater power. So scenario B has the higher power because the sample size is larger than scenario A. The greater the sample size, the more likely I am to reject. And the reason is it decreases the amount of sampling variation. All right, the sample variation gets closer and closer to the theoretical. All right, or the sample gets closer and closer to the actual. So decide which scenario A or B has the higher power. Explain briefly. So we're looking again, and we sit there and go, test A is run, and we look and go, oh, wait a second. This one, alpha for B, is bigger, 0.10, 0.10 is greater than 0.05. The larger the alpha, as alpha goes up, power goes up. So in this case, scenario B has the higher power because it has the higher alpha. Scenario B has the higher power because it has the larger alpha value. All right. This scenario will take care of problems 10, 11, and 12. A medical research team is investigating the benefit of a new surgical treatment that is thought to reduce inpatient recovery time from an invasive surgery. The new surgical technique is thought to be of similar health risk to the patient, but requires a complete redesign of the hospital's operating rooms and the purchase of new equipment. The current treatment average in patient recovery time is 73.5 hours. That is quite a long time. So that's just over 3 days. I didn't know they kept people in the hospital that long these days. But anyway, just over 3 days. So explain a type 1 error in the context of this problem. Once again, when we're doing these type of problems, we have to define, we have to give our null and alternative hypothesis, and we have to define our parameter. So in this case, the claim is that it's 73.5 hours, and they're looking to reduce, and because they're looking to reduce, we're going to say it's less than, right? So let mu equal the true population mean of number of hours of recovery time for the new procedure. Then we are still asking the type 1 error, so I need to take the time and I need to define what a type 1 error is so I can show the reader I know what it is. A type 1 error is rejecting the null given that the null is true. Then I need to put it in context. In this case, the probability of rejecting the new procedure's mean recovery time is equal to 73.5 in favor of it being less than 73.5, when in fact the new procedure's mean time is 73.5. In other words, we rejected it, we rejected this, we believe this, but really the new treatment didn't make any difference. So what's the consequence? As a consequence, the hospital will believe the new procedure will reduce recovery time and will spend money for new equipment and redesign the operating rooms for a procedure that is not any more effective than the old procedure. Waste of time and money. All right, explain a type 2. Once again, and by the way, we don't have, if you've done it above, you don't have to do it again, but I did. So you don't need to rewrite this part, but you always, whenever you do one of these problems the first time, you need to sit there and define your null and your alternative, and then you need to define the parameter in context. Secondly, we need to sit there and go, what is a type 2 error? We need to give the definition response. The definition response is a type 2 error is failing to reject a null given that the null is false. All right. What is it in context? In context, in this case, the probability of not rejecting the claim that the true mean recovery time for the new procedure is equal to 73.5 hours, given that the claim is false and the true mean recovery time for the new procedure is less. So this was false. We failed to reject it. So basically, we believe that there is no difference when in fact the new one worked. So what's the consequence of committing a type 2 error? The hospital will believe that the new procedure does not reduce recovery time when in fact it does. As a result, the hospital will not adopt a new procedure that reduces hospital stays, saves patients money, and aids in the healing process. So basically, they don't adopt the new process, and people miss out on a new treatment protocol that would have helped. Define the power of the test in context. Well, first off, as always, we need to start off and give the definition. Power is the probability of correctly rejecting a false null. Very important that you have the word false. It's not just reject, it's power correctly rejecting a null, but please use the word false. In this case, power is the probability of correctly rejecting the claim that the new procedure's mean recovery time is equal to 73.5 hours, when in fact it is less than 73.5 hours. What's the consequence? As a consequence, because the hospital rejected a false claim, the hospital will spend money to adopt the new procedure, which is effective in reducing hospital stays. Okay. That concludes the video quiz. And if you know this material, you should be in pretty good shape for type 1 and type 2 errors and power. Thank you.